Hi folks, this is Calc 2 Checkpoint Quiz 13. We're given a series to consider, and we're part A asked to find a formula for S sub k, S sub k meaning the kth partial sum. So remember what S sub k is. That's the sum from, in this case, n equal 1 to k of 3 over 9n squared plus 3n minus 2. And the hint here is partial fractions. Once we get the formula for S sub k, we're to prove the series is convergent and find its sum. So remember that the series we're looking at here is defined to be the limit as k goes to infinity of the partial sums, if in fact that limit exists. Okay, so let's get to work here. Partial fractions. Let's look at this. Remember, there's an analogy between infinite series and improper integrals. We've seen the integral test already, but partial fractions is a technique of integration we would use to integrate a function like this, and so it's not surprising we can use it to help us out here. All right, the first step in partial fraction decomposition is I need to factor this denominator. And so we play around with it. Maybe we try 3n and 3n. We need factors of negative 2 to somehow get things to add up to a positive 3. So we could do a 3n plus 2 and a 3n minus 1. And we get a 9n squared. We get minus 3n plus 6n minus 2. So that's going to work out fine for us. And so since we have two distinct linear factors, the partial fraction decomposition is going to take the form some constant a over 3n plus 2 plus some constant b over 3n minus 1. So to determine the a and the b, we can take this equation, multiply both sides by the denominator, and we get the auxiliary equation 3 equals a times 3n minus 1 plus b times 3n plus 2. So I'm just multiplying both sides by this denominator. 3n plus 2's cancel here. The 3n plus 1's cancel there. So now, if I want this to hold for all n, I can have it hold for all values x, real numbers x, and so in particular I can make some substitutions here. If I let n equal 1/3, then this zeroes out, and I'm left with b times, I plug 1/3 into that, I get 3. This gives me that b is actually 1. Another good value here would be negative 2/3. I plug that into the left-hand side, I get a 3. Negative 2/3 would zero this term out. Negative 2/3 here would give me an a times negative 3, and this gives me that a is negative 1. So this tells me that I can rewrite this fraction as negative 1 over 3n plus 2 plus 1 over 3n minus 1, which I'm going to write that as 1 over 3n minus 1 minus 1 over 3n plus 2. So this is the formula I'm going to use now for my terms. I'm going to look at this sum instead of adding up this. I'll look at it as adding up that. Alright, so we start with our partial sums. Let's look at S sub 1. That means we add from 1 to 1. So we're just adding the first term here. So I'm just going to replace n with 1. So I get 1 over 3 times 1 minus 1 minus 1 over 3 times 1 plus 2. And I simplify that. I get 1/2 minus 1/5. Now, what's S sub 2? S sub 2 is the sum of the first two terms. So that's S1 plus the second term, A2. S1 I have is 1/2 minus 1/5. A2 I get by substituting in n equals 2. So I plug n equals 2 in here. I get 6 minus 1, which is 5. Minus, I plug in n equals 2 here. I get 6 plus 2, which is 8. So here I get 1/2 minus 1/8. S3 is the sum of the first three terms. So I can think of that as S2, the sum of the first two terms, plus the third term. S2 I've worked out to be 1/2 minus 1/8. And now I substitute in 3 to get the third term. 3 times 3 is 9, minus 1 is 8. So I get 1/8 there. Minus 1 over 11. And then once again, the middle terms cancel out. I get 1/2 minus 1/11. So what we're seeing evolve here is a so-called telescoping series, where these middle terms are dropping out. And we'll do one more. S4 is adding up the first four terms. So I know the sum of the first three terms, and now I'm just adding the fourth term. So that's 1/2 minus 1/11 plus, plug 4 in, 1/11 minus 1/14. And once again, we see these inner terms canceling. That gives us 1/2 minus 1/14. So we start to see a pattern here. S sub k is 1/2 minus, when n equals 1, I had 1/5. When n equals 2, I had 1/8. When n equals 3, I had 1/11. When n equals 4, I had 1/14. And where was I always getting this number? Right, this number is always the, let me go up here, it's always the 3n plus 2 number. So 1 over 3k plus 2. So we can check that out. When k equals 1, I get 1/2 minus 1/5. When k equals 2, I get 1/2 minus 1/8. K equals 3, and so forth. Make that look like a better k. So now that I've got this, and once again, the formal proof of this formula would come from induction or the arithmetic sum formula or what have you. But this is our formula for SK. That's what we're going to use then for part B. So in part B, what's the series? Well, the sum of the series, by definition, would be the limit of the sum of the value, rather, of the partial sums. And as k goes off to infinity, I get 1/2 there. And this term is going to go to 0. So, does the series converge? Yep. So the series converges. And it converges to 1/2. So the sum of this series is 1/2. And that'll do it for checkpoint quiz 13.